Hello everyone, my name is Sumedha and today we'll study about motion of a rigid body. So we'll consider a plane, an inclined plane and a rigid body which is moving on an inclined plane, making angle theta. So in this rigid body, I'll consider two particles, particle P1 and P2. Now what is the motion of this rigid body over this inclined plane? This will move in this direction. So the velocity of particle 1 is in this direction, say V1, and velocity of particle 2 is in same direction of particle 1, say V1. So now every individual particle of a rigid body, say we have Pn particles, they have velocity in the same direction. So this is a translation motion. In translation motion, the direction of velocity is same and the object is moving from upward to downward position. Again, let us consider an inclined plane. Now we have a disc or a cylinder or any rigid body of this circular shape. So now here, इसका motion भी क्या होगा? Downward from top to bottom. Now again we'll consider some point P1, point P2 or say point P3. These three are different points on a rigid body. The direction of particle 1 or P1 will be this tangential, P2 की direction, this velocity, and the direction of P3 or the velocity of P3 here will be 0 because this is touching the surface, this is in contact with the surface. So here motion is of what type? Motion, translation motion तो है because the object is moving from upward to downward. Translation motion plus there is another motion which is there in this rigid body, that is rotational motion. So basic difference, if we see in motion, that how we can differentiate between translation motion and rotational motion is that in translation motion, velocity of different particles of a rigid body is in same direction, but here the velocity of particles in a rigid body are of different direction. तो अब rotational motion को define करने के लिए what we'll do, हम rigid body की axis को fix कर देते हैं. Say we have this rigid body and we fix the axis, say z axis, and this axis is called axis of rotation. This is for rotation motion. रोटेशन मोशन को स्टडी करने के लिए हमने एक्सिस फिक्स कर दी. ये एक रिजिड बॉडी है ऑफ इरेगुलर शेप. सो जो इसके पॉइंट्स होंगे या जो पार्टिकल्स इस रिजिड बॉडी के होंगे, दैट विल बी से P1, P2 और P3. देन जितने भी पार्टिकल्स है रिजिड बॉडी के अंदर, दे विल फॉलो अ सर्कुलर पाथ because हमने एक्सिस फिक्स कर दी है and we are rotating this rigid body in this direction. So every particle, every individual particle of the rigid body is following a circular path, say radius R1 and center C1. Again we have this. This is again follow a circular path of radius R2, center C2, and here for P3 radius is 0. For P3 radius is 0, that means this particle is lying on the axis of rotation. So this was the basic idea about rotation. Now let us discuss about center of mass. For center of mass, we have considered x-axis and a system of two particles. One particle is of mass m1 and another particle is of mass m2. m1 is placed at a distance of x1 and m2 is placed at a distance of x2. And here C is the center of mass which is at a distance x. That means जो system है मास 1 एंड मास 2 का, that means दो पार्टिकल का जो सिस्टम है इनका सेंटर ऑफ मास हमें फाइंड करना है. So let's do that. From here we have x is equals to m1 into x1, mass of the first particle into distance of the first particle from the origin, m2 and x2, upon total mass of the system, where x denotes the position of center of mass. Say now, if m1 is equals to m2, then x is equals to x1 plus x2 upon 2. That means अगर मेरे जो दो masses है वो equal है तो जो center of mass होगा two particle system का that will lie exactly between the half of m1 and m2. That means the average of x1 and x2. We can consider a plane. This was for one dimension. If we consider a plane or two dimension, say we have 3 points P1, P2 and P3. Coordinates xy, x1 y1, x3 y3, x2 y2. तो हमने इस सिस्टम का सेंटर ऑफ मास निकाला है विच हैव 3 पार्टिकल. तो यहाँ पे सेंटर ऑफ मास के दो कोऑर्डिनेट्स रहेंगे, एक x कोऑर्डिनेट एंड एक y कोऑर्डिनेट. सो फॉर x कोऑर्डिनेट m1 is the mass of p1, m3 is mass of p3 and m2 is mass of p2. So m1 into x1 plus m2 into x2 plus m3 into x3 upon m1 plus m2 plus m3. This was for x. Similarly, for y, we have m1 into y1 plus m2 into y2 plus m3 into y3 upon m1 plus m2 plus m3. That means total mass of the system. So this was for a particle or a system of 3 particles. Now again if we say m1 is equals to m2 is equals to m3 or say capital M, then what we'll get? X equals to x1 plus x2 plus x3 upon 3 and y is equals to y1 plus y2 plus y3 upon 3. So let us journalize the center of mass. If we have a system of n particles, then we can write x is equals to m1 x1 plus m2 x2 plus up to so on mn xn upon m1 plus m2 plus mn. Or we can write as summation mi xi upon summation of mi. Or x is equals to summation mi xi upon capital M, where summation of mi is equals to capital M, that is total mass of system. Total mass of system. So this is the most general expression for center of mass. Similarly, we can write for y coordinate, that will be y is equals to summation of mi yi upon m. And for z coordinate, z is equals to summation of mi zi upon capital M. So these were the three center of masses for three coordinates. This was all about rigid body. And if we talk for a continuous body, that means the particle between the bodies have not enough spacing. They are tightly or closely packed. So the body is continuous. So what is the center of mass for continuous body? Let's look after that. So these are the center of masses for a discrete system. If we talk about continuous system, for continuous system, spacing between particles is very less or small. So for continuous particle or for a continuous system, consider this. What we'll do, we'll divide this into n numbers. Into n numbers, we'll divide this and each have mass of delta m. Mass कितना रहेगा each element का? Delta m. So for x coordinate, we can write summation delta of mi xi upon summation delta of mi. Now अगर मैं n जिसको मैंने डिवाइड करा है into n particles, मैं उसको बहुत इंक्रीज कर देती हूँ. n is increased and delta m is decreased. That means जैसे मेरा ये पार्टिकल है, अगर मैंने इसको 3 पार्ट्स में डिवाइड करा है 1, 2, 3, तो जो इंडिविजुअल डेल्टा एम रहेगा वो ज़्यादा होगा. जब मैं इसको 4 पार्ट्स में डिवाइड कर दूंगी तो डेल्टा एम डिक्रीज हो जाएगा. 5 पार्ट्स में डिवाइड करने में डेल्टा एम और डिक्रीज होएगा. तो व्हाट आई एम डूइंग, आई एम इंक्रीजिंग एन and thus my delta m is decreasing. Same I have done here. So now what we'll get, we'll do integration of delta mi, which is equals to integration of dm, and we get m, where m is the total mass of system. Similarly, if we'll integrate delta of mi xi, we'll get x dm. Delta of mi yi, we'll get y dm. And delta of mi zi, we'll get z dm. So, for continuous body, we have x is equals to 1 upon m integration of x dm. We have just substituted the value into this. Delta of mi becomes capital M and summation delta of mi xi is integration x dm. So we get this. Similarly for y, 1 upon m integration y dm and z 1 upon m integration of z dm. So this is for continuous body center of mass and this is for discrete body center of mass. Now let's talk about concept of reflection symmetry. We'll discuss and learn about reflection symmetry through this example. I have considered a road whose length is L, whose length is say capital L and radius of this road is much smaller as compared to length. Now, we are asked to calculate the center of mass of this road and this is placed on a x-axis and this is origin or we can say its geometrical center. So what reflection of symmetry concept says, for every element dm, we have considered an element dm at a point x, y, z. This is a one dimension, so we have x-axis only. So at a point x, one can take element dm at a point minus x, y and z, minus of x, minus of y and minus of z. So if this is my x, I have considered this portion of dm, this is my x. There is another same mass element dm with negative sign, minus of x. If we have this condition, then the center of mass coincide with geometric center. So इस रोड का center of mass कहाँ होगा? Geometric center पे, center of mass. इस एप्लीकेशन में या इस कंसेप्ट में we have rings. अगर हम ring का एग्जाम्पल लेते हैं, discs, spheres, thick rods with circular और rectangular cross section, इन सब का जो center of mass है वो coincide करता है with their geometric center. This is because of reflection of symmetry concept. So now let's solve a numerical problem for center of mass. Find the center of mass of three particles at the vertices of an equilateral triangle. Masses are 100 gram, 150 gram and 200 gram respectively. Each side of triangle is 0.5 meter long. तो हमें जो भी इंफॉर्मेशन न्यूमेरिकल में दी हुई है उसके अकॉर्डिंग विल ड्रॉ फिगर. A triangle ABC, A is 0, 0 and mass is 100 gram, mass is 150 gram and mass is 200 gram. So this is 0, 0 and we have given each side is 0.5 meter long. So this is 0.5 meter long. So coordinates of B will be 0.5, 0 and coordinates of C will be 0.25 by root 3, because we know the two coordinates and we can calculate midpoint, that will be equal to 0.25, 0, and with this help we know coordinate A, we know coordinate B, we can calculate coordinate C. Now let's write a formula for center of mass. We have x1 m1 plus x2 m2 plus x3 m3 upon m1 plus m2 plus m3. So I'll get x equals to mass first क्या है 100, coordinate x 0 plus second mass is 150, coordinate x2 is 0.5 plus next mass is 200 and coordinate is 0.25 upon sum of all the masses 100 plus 150 plus 200. So I'll get x is equals to 5 upon 18 meter. Similarly, we'll calculate for y. For y, m1 y1 plus m2 y2 plus m3 y3 upon m1 plus m2 plus m3. So m1 is mass 100, y coordinate is 0, next mass is 150, y coordinate is again 0, plus 200, y coordinate is 0.25 upon root 3 divided by total mass 100 plus 150 plus 200. So I'll get my y is equals to 1 upon 3 root 3 meter. So center of mass of this system, we get coordinate for x 5 upon 18 comma 1 upon 3 root 3. So this is my answer or solution for the 3-particle system. This was all about center of mass concept. We'll see you in the next video.